So in the first question, according to the Arrhenius theory, a substance that yields hydrogen ions as the only ion in the aqueous solution is, well, we have to look at what does Arrhenius mean. Arrhenius means that acids start with a hydrogen and bases end with a hydroxide or OH. This is saying Arrhenius, it yields a hydrogen, gives off a hydrogen. It has to be an acid, choice C. For number 2, what are two Bronsted acids in the reaction shown? A Bronsted acid, by definition, is something that donates a proton or a hydrogen. So we look here, HPO4 and H2O. The H from the PO4 gives it to the water molecule, so we end up with H3O+. So the hydrogen is donated to the water, so HPO4 is the acid. In a reverse reaction, H3O+ becomes an H2O. So the hydronium ion here, H3O+, donates its hydrogen to the PO4, making it HPO4. So the hydronium ion, H3O+, is the acid here. So choice B would have been your response. In the next set of questions, number 3, what is a conjugate acid-base pair in the reaction? So we look here, water is going to, so we're conjugate acid to conjugate base. The hydrogen iodide here and water, the hydrogen iodide gives a hydrogen to the water, become H2O, becomes H3O, so HI has to be the acid. And what does it turn into? It turns into an iodine ion, so that must be the base. So choice C would have been your answer there. Number 4, if hydrochloric acid and water react together in an acid-base reaction to form their Bronsted-Lowry conjugates, the products would be, so HCl plus HOH, you have the hydrochloric acid right there, you have water acting as the base, so the HCl is going to donate the hydrogen to the H2O, making it H3O plus, and then Cl minus. So it should be choice D for that one. Number 5, according to the Bronsted-Lowry theory, an acid is, you have to just have memorized, an acid is a proton donor, choice A. Number 6, which equation represents a neutralization reaction? Any neutralization reaction or titration reaction is an acid plus a base. Acids start with H, bases end with OH. That's Arrhenius theory. Makes a salt and water. So this is the only one with water here. Well, that one has water too. But this salt, KNO3, we've got that as ionic. So we have a metal to a nonmetal. We have that polyatomic ion there. And here in letter C, why this isn't it. This is an acid, but CaCO3 is not a base. So that's not an acid-base or titration reaction. Number 7, the pH of 0.1 molar CH3COOH. Well, you would look that up on table K and find that that's acetic acid. So acetic acid has an acidity greater than 1 but less than 7. It's in that acid range. Number 8, the H3O plus or hydronium ion concentration of a solution is 1 times 10 to the negative 5th moles per liter. This solution is, well, when we look at it, 10 to the negative 5, we take that negative log, and that ends up being 5. So it has a pH of 5, and a pH of 5 is less than 7, so that's acidic. Should have been choice A. Number 9, how many milliliters of 5 molarity sodium hydroxide are needed to exactly neutralize 40 milliliters of 2 molarity HCl? This is a titration neutralization formula. Should have used the reference table. It's molarity of the acid times the volume of the acid equals molarity of the base times the volume of the base. So 2 times 40 equals 5 times x. 2 times 40 is 80, and then 80 divided by 5, and you should have had the answer, let's see, 16 right here, choice C. So you need a calculator for that one. Number 10, in a solution, litmus is blue. The pH of the solution could be, it should be 10. You're looking at table M on this one to do that. Table M, look for common indicators. You want to look up litmus. Where is litmus blue? And you get choice A. Number 13, what is most likely the pH of a solution as a weak acid? Well, really strong acid is 1. Really strong base is 14. Neutral is 7. So 5 would be a weak acid, choice B. Number 14, acidic solutions are those that contain an excess of, well, to make an acid, you have hydrogen ions being released, choice C. So you're going to have excess of hydrogen ions, and you have more of those than you have those hydroxide ions. 15 is a table M question where you have indicators like bromethymol blue, thymol blue, and methyl orange. The table shown was compiled from experimental laboratory data. At what pH would all three indicators appear yellow? So yellow would be less than 6.2 in bromethymol blue. Yellow would be greater than 2.8 in thymol blue. So we got bromethymol blue being less than 6.2, thymol blue being 2.8 or greater, methyl orange, yellow 4.4 or greater. So now we're looking at a range somewhere 4.4 to 6.2. Anywhere in that range, 4.4 to 6.2, we have choice C, 4.7. Number 16, as HCl is added to a basic solution, so you're adding an acid, hydrochloric acid, to a base, the pH of the solution should go down because you decrease going towards your acid side, 1 through 7. So we should have a decrease in our pH. Number 19, what are the relative ion concentration of an acid solution? If it's acidic, we should have more hydrogen ions, that's the acid ion, and less hydroxide ions, that's the base ion. So A for that one. 20, a 0.1 molarity solution of hydrochloric acid contains, well, it's acid, HCl. So it's going to have more of the hydrogen ions, that's more hydronium, they're saying in this case. This is the same as H+, H3O+, and less of the hydroxide. Should have had B on that one. For 23, the compound sodium hydroxide dissolves in water to yield. Well, it's a base. It ends in OH. Arrhenius theory ends in OH. You're a base. So you're going to have hydroxide ions, and that's a negative ion, OH minus. So choice A was your answer there. 24, similar question. Potassium hydroxide is classified as an Arrhenius base because potassium hydroxide categorized Arrhenius base because there's the hydroxide at the end. That's an OH minus ion. So it's letter A, the hydroxide ion. For number 29, red litmus will turn blue when placed in an aqueous solution of, so you had to look at your table M for this one, and red litmus turns blue in a base. So we have sodium hydroxide being our base. Remember, it's not this CH3OH, that's an organic alcohol. Alcohols are not basic. Number 30, which products are formed when acid reacts with a base? You need to have memorized when acids and bases are mixed together, you make a salt and water. Choice D. They make salt and water. 31, one sample of a solution with a pH of 10 is tested with a phenolphthalein. Another sample of a solution is tested with litmus. In the solution, the color of litmus is, well, looking at table M, your litmus should be blue in a pH of 10, and phenolphthalein should be pink in a pH of 10. 32, given the reaction, the carbonate ions plus water make yield HCO3 ions and OH minus ions. The water molecule serves as, so water, is it donating a proton or accepting a proton? So I look here, the water turns into OH minus, so it loses one. So water is donating a proton to CO3, making that HCO3. So if you donate a proton, you're acting as your acid and you're a proton donor. So choice C for that one. 39, if 50 milliliters of 1 molar NaOH solution is needed to exactly neutralize 10 milliliters of a HCl solution, the molarity of the HCl solution is, so you should have your calculator out for this one. This is a table T question. You look up neutralization or titration. Molarity of the acid times the volume of the acid equals molarity of the base times the volume of the base. You should have had one, let's see, the acid side first. So X times 10 equals 1 times 50. 50 divided by 10 is 5, so your answer should have been C, 5 molarity for your hydrochloric acid. Number 40 was also a molarity of the acid times the volume of the acid equals molarity of the base times the volume of the base question. Should be set up 2.5 for the molarity times X equals 5 times 15. Then you solve that algebraically, and you should have gotten 30, choice C.